So here we are again with the latest installment in the StratoBalloon series. It's been over 3 months since our last one. I know.
Yep, we've just been lounging around in our PJs all winter.
Yeah, as if. Today's podcast will focus on the radio transmitter. Katherine and I got our ham licenses way back in November, and it was all in preparation for using a Radiometrics NTX2 transmitter.
Through a series of stops and starts, we've actually been working on getting a circuit using this chip, an Arduino sketch for transmitting data through this chip, and an equipment/software to receive and decode that data.
This winter has been particularly difficult. Tons of snow and bitterly cold, and I ended up being sick for quite literally a month, so the challenges have not just been technical.
However, with some excellent help from some fellow hams and a lot of determination, we feel like we're now on the right track. We're starting with a process that is detailed at the UK High Altitude Society's wiki site. They describe a test circuit and some sample code for this, and we'll include the exact link in the credits and the podcast notes.
Before we get to the functional solution, though, we thought it would be instructive to show you the major dead end that we walked down. Here's the equipment we started with. The NTX2 chip itself, the Arduino, two 4.7K ohm resistors, and a 47K ohm resistor, our breadboard, and of course, our Baofeng UV5RA FM transceiver. Not shown here is an audio cable that we would be using to connect the speaker of the transceiver to the input jack of our computer's sound card.
To get started, we dropped the NTX2 onto the breadboard. Our guide was this circuit from the UK High Altitude Society wiki page. Here I am, part of the way through the process of wiring our chip up.
Katherine was working so hard on this step, I think she actually fell asleep at the workbench.
I did not. I was trying to make sure I had the wires lined up for the right pins on the chip. Asleep indeed.
After getting all of the wires and resistors in place, our breadboard looked like this.
Hey, it kind of looks like a squid.
A squid.
You know, from Minecraft.
I'm not saying it.
You really need to play more Minecraft.
You really need to play less Minecraft.
Anyway, for our first test, we hooked it up to the Arduino. The red wire to 5 volts, black wire to ground, and white wire to digital pin 13, and loaded up the test sketches shown on the UK HAS page. We tuned our radio to 434.65 MHz and were immediately greeted with a warbling. When we disconnected the Arduino, the warbling stopped, so we thought the transmitter circuit was working. The real test, of course, was being able to decode the data that came over the radio waves. To do that, we hooked up our radio speaker output up to our computer's microphone jack via a cable, and then used pieces of software called DLFL Digi, which was a free download.
I configured it according to the UK HAS page, but I could not get the waterfall patterns to match what I was seeing on the screenshots on that site. More to the point, all we could see in the data box was gibberish. The phrase RTTY test beacon never appeared. I ended up playing with it for a couple of weeks, trying various settings, but to no avail. I even tried other software for decoding data being sent over radio waves, but got similar disappointing results. That's when I decided we needed help. There was a user group that I was a member of where we discussed technology, all sorts of technology, and we had a meeting coming up. Katherine and I had presented the balloon project there before, in a far earlier stage of development, and I thought we could present this problem there. What's more, 2 of the regular attendees were ham radio operators, so we were hopeful that we'd be able to figure out what we were missing with this.
The meeting was held just after work, and Dad picked me up just before it started. We set everything up, walked the group through the UK HAS site, showed the circuit, and let them hear it in action, and showed them the DLFL Digi trace in action. We tried several different things, and then one of the group, Mike, suggested trying to hear the transmitter over the receiver in his truck. He ran down and took a recording on his phone.
Now, given that we were in a 3rd floor conference room, and the transmitter didn't even have an antenna hooked up to it yet, we were all surprised to find that he was able to pick up anything. But he was, and more to the point, what he recorded sounded vastly different than what we were hearing over our Baofeng handheld radio. Here is the difference. First, the bowel fang. And now, what we heard from his truck's receiver.
Listening through to the transmission through our radio was like listening with cotton in our ears. The difference between the Biofangs and Mike's radio was night and day.
No kidding. In fact, when we piped the recording Mike took through DLFL Digi, it was a little rough, but we were able to finally get the waterfall to look like what the UKHAS site was showing in their screenshots. And we were able to get the test beacon data to come through.
Well, mostly. Instead of RTTY test beacon, the data was coming through occasionally as RTTY test bacon.
Which isn't a bad thing either. At any rate, this experiment convinced us that our radio was the culprit.
We later reread the tutorial a little more carefully and even found the bullet at the beginning that said radio/SDR capable of receiving SSB at 434 megahertz band. The key here was SSB, single sideband. Our Biofang handheld radio isn't capable of that at all.
Yeah, exactly. Always helps to read the instructions carefully, Mark. At any rate, now we knew why we couldn't receive what the NTX2 was putting out. Now the question became, what to do next for a receiver? We discussed it further at the user group meeting, and given our budget, the guys suggested picking up a software-defined radio, or SDR, on eBay. I found one for less than $25, a New Elec R820T. From the time I unboxed it until the time we got it decoding the test beacon signal from the NTX2 was about 2 hours flat. I honestly was amazed at how smoothly it went. I'll be posting a more technical write-up of the details of our configuration later.
Amazed might be putting it a bit lightly. Dad actually threw up his hands like he scored a touchdown when he got it working. It was actually pretty hilarious.
Hey, it was pretty awesome to see the data coming off the air correctly, although there wasn't any bacon involved this time.
That was the disappointing part. At any rate, Dad's first attempt with the SDR was actually using the NTX2 still on the breadboard. We knew we would eventually need to get the chip onto a permanent spot on the instrument cluster, and for that, we would need to mount it to a piece of PC board. Luckily, we had a piece that suited the purpose nearly perfectly, so it made cutting it out easy. Once I had it cut out, we got the NTX2 soldered on. And then we could start attaching the resistors and other wires we needed to it.
Katherine and I were getting a little worried, well, more than a little worried, about how close these connections were getting. Naturally, after we had everything soldered down, we had to retest it, and it worked beautifully. Here's our setup in action. The Arduino transmitting a test signal, and the SDR receiving and decoding it via DLFL Digi. So I'm going to show you what the waterfall trace looks like once the beacon, using the little test script that we were writing for the Arduino. So here we have the little test script running, and the script itself just prints out my call sign, KD8VZA RTTY test beacon, over and over again. That's being transmitted through the Arduino here, and you can see the LED, the onboard LED is flashing away madly, and that's being transmitted through that the NTX2 chip. That's being picked up through the New Elec SDR receiver sitting on my desk. The software that's actually picking that up is SDR Sharp, and you can see the trace there. And if I turn off my speakers, you can hear that. And that receiver is being then piped through software through DLFL Digi, and then the trace is coming there through the waterfall there and being decoded back into the text. So this is the basic setup that we're going to be using on the balloon to transmit and receive data off the balloon. We'll be using a script, a sketch like this, to transmit longitude, latitude, and altitude, and maybe some other data. And then on the transmitting side, and then this is the actual chip that we'll be flying. And then on the ground, we'll be using this guy and a much more powerful antenna to receive it, to receive that data and get it back.
The next step will be to attach an antenna to the NTX2 and work on finding or building a better antenna system for the SDR receiver. We also need to attach the NTX2 to the instrument cluster and get real data transmitting through it, which means updating our balloon sketch to use it.
That one was definitely the most exhausting episodes to produce.
Are you saying you felt even more lost than trying to get the GPS chip to work?
Absolutely. I mean, with the GPS code, oh, that was terrible.
Gotcha. Squid!